this video I will explain the basics of data transformation that can be done in Stata. Let me open Stata and let me load the data file with the help of do file that I have already saved. This do file, open this do file and let me open the Excel dataset by using this Excel command, import Excel command. So if I run this, my dataset is imported into this data's memory. Now the simple data transformation that can be done in Stata are defining a new variable from the existing variable, doing log transformation, ratio transformation, growth transformation, etc. So for example, if we want to convert the GDP that is in million into billion, we use this gen command. Gen means generate. This command generates new variable. So gen GDP underscore b means generate the real GDP variable in billion unit equals to RGDP divided by 1000. So this is the order for Stata to divide the real GDP by 1000 and create a new variable called RGDP underscore b. If we select this command and run this command, a new variable is displayed here under variable list, and if you want to see this variable, we can just give a command called list RGDP underscore b. So if we run this command, Stata list the new variable defined by it in billion rupees. So similarly, we can convert population into billion by simply using gen command, gen population underscore b equals to population divided by 1000. So in the same way, we can define a new variable called per capita GDP by dividing real GDP by population. So the command is gen per capita GDP equals to real GDP divided by population. So similarly, we can define a new variable called a trade balance as a difference between export and import volume. So the command is gen trade balance. This is the name given by us, and this is the name of new variable. This is given by export minus import. So if we run these two commands, the two new variables will appear under the variable list. So now suppose we want to calculate the export import ratio. We can do it by the same command gen xm ratio. This is the variable name given by us. You can give any name to this ratio. So this is given by export divided by import. So if we run this command, the export import ratio variable appears in this list, and the value of the variable can be seen by using this browse button and going to the last of the data set. So this is the trade balance defined by us. This is per capita GDP, this is GDP in billion, and this is export to import ratio. So in the same way, we can use the log command for defining log transformation. So suppose we want to take the log values of GDP, real GDP variable. So the command is gen lrgdp. Again, this is the name given by us, and you can give any name. So this is given by log bracket real GDP. So this command calculates the log value of real GDP. If we run this command, a new variable lrgdp appears here. So if we want to see the value of our new variable, we can simply type list real GDP, which is the original variable, and lrgdp, which is the new variable. To see the first 5 observation only, we just type in 1 to 5. So this shows the values of real GDP and log of real GDP in first 5 observation only. So if we run this command, we see the result. This is real GDP, this is log of this value. So in this way, we can define a new series which is the log of the original series. So similarly, we can take the log of CPI, generate LCPI equals to log of CPI, list LCPI. So this calculates the log of CPI and list here in the result window. So we can calculate the growth rates of variables. For this, one new command should be run first. This command is to tell Stata about the time variable that is used by our dataset. The time variable is required to calculate growth rate. So our time variable is year, so the command is tset. Tset command is for setting the time set command. So tset year means this command tells Stata that our time period is year. So while calculating growth rate, the growth rate should be calculated over the years. So if we run this command, the result window says that time variable is year 1975 to 14, and the difference between time period is 1 unit. So now we can calculate the growth rates of variables over time. For example, the growth rate of CPI is called inflation. Generate inflation calculates the new variable called INF. So this is simply defined by current year CPI minus previous year CPI. This operator L dot tells Stata that the value of the observation should be taken from the previous period. So L dot CPI is the value of CPI in the previous year. So current value of CPI minus value of CPI in the previous year divided by value of CPI in the previous year into 100. So this just calculates the growth rate of CPI, or in the terms of economics, it calculates inflation. So if we run this command, and if we want to see what is the rate of inflation over the first 10 years, we can use this command list INF in 1 to 10. So if we run this command, this simply lists the value of inflation calculated by Stata in the first 10 years. So by using the same logic, we can calculate the growth rate of population, we can calculate the growth rate of GDP, and see our calculated growth rates over time by just clicking this browse button and going to the last. So this is inflation calculated by us, this is population growth rate, this is growth rate of real GDP. So the next transformation that is used most widely in time series regression is the first difference transformation. The first difference transformation creates simply a new variable as the difference between the value of variable in the current period and the value of the same variable in the previous period. So first difference of real GDP equals to real GDP at current year minus real GDP at the previous year. Again, this lag operator L dot tells Stata to take the value of real GDP in the previous period from the previous period. So if you calculate this, draw on this and list real GDP and difference of real GDP from 1 to 5 observation. Yeah, so this is the real GDP in first difference form. So how Stata calculates this variable is that Stata simply subtracts the later observation, the previous observation from the later observation. So this 5032 is simply the difference between this value and this value. This 2000 is difference between this value and this value. So this is called first difference transformation, and this first difference series is used widely in time series regression models like error correction models, bar models, etc. So these are the basics of data transformation. By using the same logic, you can transform the data in any way you like. So this is only basics. For further data transformation issues, watch the videos in the series that come to next.